The graph of a quadratic function. Quadratic function defined by f of x equals ax squared plus bxc can be written as y equals f of x plus a times x minus h, the quantity squared, plus k, where a does not equal 0. We can find that by completing the square. Or if we went through completing the square on this process, we would find out that h equals negative b over 2a, and that k is f of h. So when we put h in this, we put this h in this function, we'll get k. Now the graph has the following characteristics. Its parabola is at hk, and the vertical line, h equals x, is an axis. It opens up if a is greater than, if positive, and down if a is negative. It's broader than the graph if a is less than 1, the absolute value is less than 1, and narrower if the absolute value of a is greater than 1. The y-intercepts, f of 0 equals c, would be a y-intercept, and the x-intercepts can be found by using the quadratic formula. And if the discriminant b squared minus 4ac is greater than 0, you'll have 2. If it equals 0, then the x-intercept is only the negative b over 2a, and if it's less than 0, there are no x-intercepts. Let's graph this using these techniques. H equals negative b over 2a, so that will make this negative 24 over 2 times negative 3, or negative 24 over negative 6. That will mean it will equal 4. So h is 4, k is g of 4, so that will be negative 3 times 4 squared is 16, plus 24 times 4 minus 46, or negative 48 plus 96 minus 46. This will be 50, and negative 48 is 2. So my vertex is at 4, 2. That means my domain is negative infinity to infinity. My range, oh, does this open up or down? Oh, a is negative 3, so it opens down, so the range will be negative infinity to the vertex y value 2. The axis of symmetry will be x equals 4, notice an equation, graphing it, 2, 2, numbering by ones. Vertex is at 4, 2. It opens down and is skinnier by a factor of 3. So if I think of my 1, 1, I'll take 1 and take the second 1 times negative 3, going down 3. And then this is mirrored across the axis of symmetry. My next step is the 2, 4, but take the 4 times negative 3. It will be negative 12, which takes me clear down here, mirrored across the axis of symmetry. And now I can draw my parabola. This parabola, since it opens down, has a maximum point, a highest point it gets to, and the highest would be a y value, and the highest y value is 2, the y value of the vertex. In this one, the same technique, my h equals negative b over 2a, negative of negative 10 will be 10 over 2 times 1 or 2, so h equals 5, and k equals f of 5, 5 squared is 25, minus 5 times negative 10 will be minus 50, plus 21. These two positives will be 46, and negative 50 will lead to a negative 4. So the vertex is at 5, negative 4. The axis of symmetry will be x equals 5, always an equation, always an ordered pair. The domain will be all real numbers. And the range, oh, does this open up or down? This is a positive a, so it opens up, and it will start then at the y vertex value of negative 4 and go to infinity. This will also mean that this parabola will have a minimum y value of negative 4. Graphing it, 5, negative 4, we'll take it here, and since this is a is 1, this is an easy, up 1 and over 1, mirrored, over 2 and up 4. We even have room for over 3 and up 9, again mirrored across the axis, and we can draw our parabola. Not always the best at drawing the parabola on the bamboo pad. Now sometimes they ask us to find the x and y intercept. The y-intercept is really easy to find because we know when the y-intercept, x is 0. When I fill that in the equation, 0, 0 plus 21. So it's really the c value in this form. For the x-intercept, well, this way we can find it a couple ways. This one's easy because these points were right on the x-axis, those points being 3, 0 and 7, 0. If it wasn't quite so easy to find, I would take the equation, set it equal to 0, and solve it. This one you can tell factors easily because we get the whole numbers. It will give me the x-intercepts.